my channel, and today my topic is all about neutron stars. Neutron stars are the remains of a super large red supergiant, which you can find and learn about in my previous topic. Neutron stars are not actually blue like in this picture, but in the night sky they can appear blue. Neutron stars are actually very small compared to our sun and even our Earth. Compared to our Earth, it is only about the size of a large city. But neutron stars have also a lot of big abilities, such as massive gravitational forces, and also they send out pulsars. Since 1967, we have found thousands more of neutron stars. Here are some very cool facts about it. If you only dropped an object 3 feet above a neutron star's surface, by the time it gets all the way down to the surface and touches it, it would accelerate to 4 million miles per hour. This is because of its strong magnetic force. You can think about neutron stars like a big and huge magnet because it sucks in everything within its magnetic field. When you hover a magnet over some paper clips, it will also start to pull onto the magnet because of the force. But here, neutron stars are so powerful that the gravity on it can pull you down to a flat pancake. In our solar system, or outer space, we predict that there are 100 million neutron stars that we haven't discovered, but we are going to discover soon. A neutron star's surface is also billions of times stronger than steel, so think about all the structures we could make out of it. It'd probably even be bulletproof because it's so strong. And lastly, the highest mountains on neutron stars are only 5 millimeters tall. Think about Earth. There's so many big mountain ranges, which are thousands of feet above Earth. But on a neutron star, even though they're small, the highest mountains are only 5 millimeters. That's so small. It's less than your height. A neutron star sends out these radiation beams called pulsars. The first one was found in 1967 by a Cambridge student. And astronomers have used this way or method to find out more neutron stars and how fast they orbit. Pulsars are coming from the North Pole and South Pole of a neutron star, and they emit beams of radiation from its core. And as it spins around, it will direct the radiation beams into different parts of space. And sometimes only some of these radiations will go directly into Earth, so that's when we see it. That's why it appears to us that it's flashing on and off, even though it's spinning and not going off. A pulsar can be 700 times a second, which is the most fastest it can be, and the most lowest pulsing amount was only 5 pulsars per second. Think about that. For 700 times a second, you wouldn't even be able to see it flashing on and off because it's so fast. Inside a neutron star is all made of neutrons, but its surface is very solid. It has a surface or a crust of 0.16 miles, and as you get down, there's an element that you cannot find on Earth. It's made of liquid, but it's actually the most strongest element that we have found so far. It's made out of entire neutrons. And these neutrons are tightly packed together because of the gravity. Its immense gravity will fit as many neutrons as it can. So even though a pinhead of these neutron stars will have 2 of Earth's largest supertankers, or cargo ships, the weight of 2 large supertankers are equivalent to 1 pinhead of neutron star matter. That is a lot compared to our weights on Earth. Neutron stars are kind of like dumbbells because the more matter you pack into dumbbells, or the more dense the dumbbell is, the more likely heavy it's going to be. So if you have air is super light, but if you jam everything together, like metal has a lot of atoms jammed together, it's going to be more heavy. This is kind of like an idea of a neutron star. The core is even made of neutrons, and as it gets inner and inner, it's more dense. The size of a neutron star is actually pretty small. Compared to a massive red supergiant, it's only like a germ. This is the size of Vancouver, Canada, compared to a neutron star. But they're actually way more powerful than you think. Only a tiny bit of it crashed into Earth will have Earth be coming into a catastrophic damage, because this neutron star's matter or weight will destroy a large amount of Earth. So that's why we never want that to happen. But luckily, the closest neutron star that we have found was only 400 light years away, which is still pretty far compared to other stars. The density of a neutron star is what everybody is amazed by. In this picture, it has a soccer ball, and it's equivalent. The matter on a neutron star is equivalent to Mount Everest if you only were to pick up a soccer ball amount of matter on a neutron star. Think about Mount Everest. It's so big, and it even counts underwater, so you wouldn't even be able to pick up just one tiny drop of it. I think neutron stars are very cool because they have immense gravity. And I learned that it's the densest material that we have on Earth, that we find on Earth, and I hope that we find more neutron stars in the future. I hope you like and subscribe to my channel, and thank you for listening.